Hello. Today we're going to talk about Topic 3, Section 2, Triangle Trigonometry. So basically, all of geometry. Okay, this is where this comes from. The biggest part of geometry and the strongest shape out there is, of course, the triangle. So here you can name them by their sides or by their angle. You should know this vocab. Over here you have SOHCAHTOA. So that was the acronym you wanted to remember. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Blah, blah, blah. Like, let's say this is our theta. So the hypotenuse is always across from the right angle. The opposite is the one not touching it. So this would be considered the opposite. And this next to the theta would be considered the adjacent. Okay, so identifying that is the biggest part. Okay, I can't tell you how many times I've seen kids mess that part up. All right, now let's do some problems. Oh, wait, no, similar, right? Triangles. Okay, how do I know if a triangle is similar to another triangle? Okay, well, here I would say that triangle ABC is similar to triangle DEF, okay, because the corresponding sides match up. So AB to DE is a ratio 5 to 10. BC to EF is a ratio of 12 to 24. AC to DF is a ratio of 13 to 26. And all of them can be simplified to the same ratio, which is 1 to 2. So that's how you know the triangles are similar. So the angles are the same and the sides have a relationship. Okay? All right, so some examples. Here we have a right-angled triangle, and cosine A is 3/4. So cosine of angle A, so cosine adjacent over hypotenuse. So now we want to find sine of A and tan of A. Well, it helps to know what this is. Well, first I'd always label my sides. So this side is the hypotenuse, this is the adjacent, and this is the opposite, because we're basing it off of angle A. So we need to figure out what x is. So it's a right triangle. Use the Pythagorean theorem. X squared plus 3 squared equals 4 squared. So x squared plus 9 equals 16. X squared equals 7. So x equals, here we're only going to use the positive because negative as a hypotenuse, or I'm sorry, negative as a side length doesn't make sense. So the square root of 7. So sine of A is, remember, sine is opposite over hypotenuse. So square root of 7 over 4. And tangent of A is opposite over adjacent. Okay, so that would be square root of 7 over 4. There's your answer. All right, the next part. So here has a hypotenuse of 22. If sine of A, sine is opposite, which is over here, and this side is adjacent, hypotenuse. So sine opposite over hypotenuse is 3 over 5. Okay, well, that opposite, we'll just call that x. So sine of A is also x over 22. So we can get rid of the 22 by multiplying it. So we get x equals 3 over 5 times 22. So x is 66 over 5. All right, now we've got that side length. And now we can plug it in to get the other ones. I don't really like fractions, and this comes out to a nice decimal. It's at 13.2. So then I'm going to use that to help me find the adjacent value. So that's 13.2 squared plus y squared equals 22 squared. And if we solve that, we'll get y equals 17.6. So this side is 17.6 centimeters, and this side was 13.2 centimeters. All right, next example. So here we've already got things labeled. We've got angle C, angle B, AC right there. So we want to find x. Okay, so I would start by labeling it. You know the part across from 90 is your hypotenuse. Across from your angle is your opposite. And here is your adjacent. So what we have is opposite and hypotenuse. So we know some trig function of 51 is going to be opposite over hypotenuse. Well, that is sine. So we can do 11 times sine 51 into our calculator. Make sure it's in degrees. And let's see. Okay, we plug that in. We should get 8.548 dot 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 to 3 significant figures. We would get 8.55 centimeters. Okay. Another example. All right, so this one, I'm going to label it the same way Cognity did. So, oh, that got a little messed up. Here we want x. This one we want y. So Km is x. Lm, or ml, is y. JL is this large side, the whole length. So that's z. And we'll just let JK, I think they called it W earlier. Okay, so find all those values. So I'm going to start with this little triangle here, because that I can easily find W and X. So why not? All right, so here we're going to use J as our starting point. Here, just so I can get my colors right. So this one, we know across from the right angle is our hypotenuse. We know next to it is called our adjacent. I don't want you to be confused by more variables. And then this one is your opposite. Okay, so we have X and W we both want to find. So that's opposite over hypotenuse. Sine of 63 is x over 10. We could even do the cosine of 63, and that is w over 10. So here we can just do this onto our calculator, and then w is just 10 times cosine 63. So if you work that out, let's see, what did we get? Oh, we got W to be roughly 4.543 sig figs. All right, and we can get X to be, I believe, 19.6 sig figs. Okay, so that really didn't make sense. I scrolled too far down and looked at the wrong X value. Sorry. It should be 8.91 to 3 sig figs. So that's what X and W are. So that was looking at the smaller triangle here. So now let's look at the bigger triangle. and we're still going to use 63 as our angle. All right, so now 10 is considered our adjacent, and z would be considered our hypotenuse, and y is considered our opposite. So here we think, what value of 63, or I'm sorry, what function of 63 should I do to get, well, I have opposite and adjacent because I want to figure out what y is. So that would be y over 10. Well, O over A is a tangent. So to get y, we need to do 10 times the tangent of 63. And that gets us 19.6 as our value. Now, notice in all my values, I didn't use anything that was rounded, 63 or 10, okay? So I just used different trig functions to get my values. Well, if I want to figure out what z is, this entire length here, well, really, I'm sorry, not the entire length, just KL. Sorry, Cognity does these things very weird. Okay, so there's a whole bunch of different ways you can do it. They suggested using Pythagorean theorem with y, so using that 19.6. So when you do that, you would do 19.6 squared plus 10 squared equals your z squared, so your hypotenuse squared. Now, how I would do that in the calculator. So first I would get my y value in there correctly. So we have 10 times the tangent of 63. So we take that value and we square it, and then we add 100 to it. And then we want to take the square root of that answer. So we do second x squared, and now I want to put that answer in there. I don't want to type it out because I'm lazy, so I do second, the negative sign, and it does my previous answer. Okay, love that function, use it. It's better than typing because you'll mess something up and it gets everything, all your decimals. Okay, so then my answer is 22.0268925, blah, blah, blah. Okay, so if we do it to 3 significant figures, z is going to be 22.0. Okay? All right, keep using the answer function on your calculator to use exact values while solving. You only round your final answer. Okay? That way you don't lose any points for accuracy. All right? Okay, so if you don't want to get knocked off for your significant figures, found this out, exam tip. Don't know why this is in chapter 3, but whatever. So write the line x. So if you want to do x is the square root of 77, you write the line with all these decimals, and then you put your final answer of 8.77. If your correct unrounded answer is seen, you'll attain your full mark. Okay? So, if it's seen, it says if, so I don't really know what the likelihood of that is, but it sounds promising, so why not do it? Okay? All right? That's how you can make sure you don't get knocked off for rounding. So put the whole decimal, so that way if this is off, I can look at that. Okay? Okay, so now using a trig function going in reverse, so finding the angle. So here we've got our triangle set up. So we want to find the size of angle GHF. So GHF. All right, so let me go ahead and label that angle theta. So that means this one next to it is the adjacent. One across from the 90 is the hypotenuse. The one across from it is the opposite. Well, the numbers we have are opposite and hypotenuse. So opposite hypotenuse means sine of theta is equal to 400 over 1330. So to get the theta by itself, well, the opposite of sine, like multiplication, opposite is division, opposite of addition is subtraction, squaring is square rooting, sine, inverse sine. We put it on the other side, and we put it with this little -1 right there. Okay, you can also call that arc sine. And how we do it on our calculator. So we do second sine, inverse sine, there you go. And we do 400 divided by 1330. So we get 17.5. So the angle is 17.5 degrees to 3 sig figs. So now let's move on to the area of a triangle. Hopefully you remember that's 1/2 base times height, but your formula booklet also gives you this fun little formula. So 1/2 AB sine C. Okay, so 1/2 AB sine C is going to be a lot nicer than trying to figure out what the height is and all this other stuff. Okay, so when you have an angle in between your two sides, you're going to literally just do 1/2 times 9 times 11 times sine of 35 degrees. So your answer is 28.4 square centimeters because it's area. There you go. All you got to do. So it happens when you have two sides and an angle between them. All right, another nifty thing to know about triangles is your law of sines. So here's your breakdown. Okay, so we can take any angle and the side across from it, so 7. So we take that 7 over sine of 30 degrees. That's got to equal, okay, this is in your formula book, all right, to, let's look at this angle on this side. All right, that side length is B over sine of 70. We can even keep going with this piece. Okay, the length of AB over the sine of angle C. All right, so here obviously this one's not as useful, so we're going to continue with this. So we're going to solve for B. So in our calculator, we're going to do 7 divided by sine 30. Then we're going to take that and multiply by sine 70, and that'll tell us what B is. All right, so let's see. We plug that in, and we should get B is 13.155. So 13.2 centimeters. It's a length. All right, to 3 sig figs. So again, I know just setting up that law of sines is a little tricky. So here you want to do that again. Set up your law of sines, see if you can get that correct. So we want to find angle F. So I'm going to label that theta to know I'm looking for an angle, so that's degrees. All right, so you should have gotten 6 over sine of theta is equal to 7 over sine of 124. Okay, so let's see, we could cross multiply since there's an equal sign. I try not to cross multiply typically because people mess it up, but we want to multiply whenever there's an equals, the numerator with the denominator, that numerator with that denominator, and then set them equal. So we end up with 6 times sine of 124 is equal to 7 sine of theta. So then we do 6 sine of 124 over 7. And then we do the inverse sine of that. And that should give us what theta is. Let's see. What do we end up? Sine, yep. Theta is 45.3 degrees to 3 sig figs. All right. All right, so now we're going to do the law of cosines. Okay, so again, it's in your formula book. All right, here we're going to find the length of side AC. All right, so CB is 5, blah, blah, blah. Okay, so using the law of cosines, the thing you want to notice with it is that C and that C are related. So you want to make sure that that C is lined up with the angle. Okay, so I think that's what trips people up with this. So we have to use 37 because that's what we have. So we know it's going to be cosine of 37 degrees. So that means the A and B are the other sides, the 5 and the 6. So we know this is going to be times 6 times 5. I know I'm working backwards. Work with me here. So 5 squared plus 6 squared. Oh, all right, so yeah, so these, again, doesn't matter which one's A and which one's B. Those are your sides. And then your angle, and then the one it equals are going to be on the ends. Okay, so this equals A squared. All right, I really hope that makes sense. So what I would do from here is plug this into your calculator and then take the square root of it. And so you should get, what, A is approximately 3.6168 if I don't want to get cut off for rounding. And then I would say 3 sig figs, so 3.62 centimeters. All right. All right, so now we're going to do another example. So on this one, again, you want to just make sure you know how to set up your law of cosines. Okay, because we have one angle and we're trying to figure out those sides. So we know it's going to end with cosine of 86. So we need it to start with the one opposite it. So 6 squared. Then we use the other sides for A and B. Minus 2 times A times 5. We're going to space that out. All right, so using your calculator, you can solve for A and get 3.6836 ... So 3 sig figs. And there you have it. All right. So here we have another example. And we want to try to find the size of angle ABC. So ABC is this angle. So again, I would set it up with cosine. Cosine of that angle, you know it's going to equal your 16 squared. And then your other angle, our other sides are A and B. And here it's just a matter of getting that cosine by itself. So you square these, get those put over to the other side, and you should end up with, what is it, 23 over 33 equals cosine theta. So we take the inverse of that, and we get our theta to be 45.8156 ... 3 sig figs gets us 45.8 degrees. Okay. Oh, wait, did it say, it said to the nearest degree. Oops. That's what I get for not paying attention. So 46 degrees. All right, almost done. Hang in there with me. All right, so I just threw a whole bunch at you, okay? There is so much you learn in geometry you just don't even realize, you know? So geometry was all about looking at a problem and finding a way. Okay, so I know there's a lot of algebra minds out there that want this. You know, they want rules, they want to follow a pattern, they memorize this, that's how they work. Okay, so if that works for you, go for it. I just like to know the rules, and then I just try stuff. You know, okay, I try law of sines. Well, I couldn't solve it, so try law of cosines. Okay, I tried it, didn't really get there. Maybe I didn't set it up right. Try again. Okay, all right, try something else. You know, that's what works for me. Okay, so I look at what I have and I go from there. Hopefully this chart helps you. Okay, if you get a little lost sometimes. All right, so this is everything you should know in section 3.2. If you have any questions, please come to class. Okay, ask me in class.